So welcome to the June 2011 meeting of the New York City Revit Users Group. I am James Van de Zandt, president of our little party here. Kind of almost joining me up here is my senior VP, Jason Chen. We have a number of other vice presidents as well. Andre is here in the back, Andre Voss. Robert Mancarini, say hi. Leonard Anderson is here. Snigda has been absent for a couple of the meetings, but I know she's very, very busy these days. And I thank you all for helping me out in managing all the logistics and getting us some great content for running our meetings here. So I always start off by welcoming our new guests. I see a lot of new faces, so thank you for coming. Anybody is their first Revit meeting? Good. You know, maybe a third or so. For those of you on the broadcast, hopefully you can hear me okay. If you're not, just send me a little chat or a question if you can't hear me. You'll be in listen-only mode. And just to be clear, if you want to close the thing, just use the little grab tab on the top to close the GoToWebinar window and get it out of the way of the screen. You can either dial in with your telephone or use your computer. Hopefully you figured that out by now. If you have any questions, again, you're in listen-only mode. Send them through the questions window, and our presenters will do their best to answer them. And for your sake, anybody here in our live audience who have questions, we'll make sure to repeat them for our webcast listeners. And we're not going to be using the raise hand feature, so don't try and use that for anything in particular. So about our group, we have now surpassed the 600 mark of registered users on our Meetup site. And that accounts for, certainly the live audience we have here, but a lot of people around the world that are listening in remotely or just, listening for updates and watching our recorded content. So we make that available for everybody as well. We started a number of years ago in April of 2006. We've been meeting in a lot of different spaces over the years, and we're lucky enough to have the space here at Pratt Manhattan Center donated to us for free from Pratt and Karen Maletsky, and a big shout out to her. And our group is on a rotating sponsorship with 4 of our fantastic New York area Autodesk dealers. This month is being sponsored by Microsoft Resources, and Harry is there in the corner. Hi, Harry. Anything to say? Anybody has any questions about the fabulous resources from Microsoft? Say hi to Harry in the corner and ask him about what they have going on. And basically every month we rotate through the 4. And so I thank Harry for providing the great food and drinks here tonight. My company, HOK, provides the AAA credits when they're applicable. Tonight, yes, we do have the AAA credit. It is available. As you recall, last time, would you do me a favor, pass that around, sign-in sheet? Our group only tracks and registers the credit for HOK employees, so if you are, check the little box that says your HOK staff. Otherwise, I have certificates that you attended. So if you need to report the credit, you'll have to self-report, but I have the certificate for you. Just come and see me at the end of the presentation. And finally, thanks to SOM for continuing to provide the webinar broadcast service for us free of charge. Thanks to Robert Mancarini. Robert Uri is here as well. There he is. So Microsoft Resources, be sure to check out our website, their website. Lots of cool stuff, events, training. Lots of people come to this group and ask for, how can I learn Revit? How can I learn other related BIM tools? Microsoft Resources, great source to start looking for that kind of content as well. Pratt has great classes. Leonard is a professor here at Pratt. He teaches some BIM for construction managers classes. Any new classes you got going on? For facilities managers as well. Good stuff, good stuff. So check that out. This is the home of the Center for Continuing and Professional Studies. And we always used to share a number of links. Lately I've been putting them on our Facebook group. So if you ever want to just check out whatever interesting links that I happen to come up with, any other person that's a member of the group can post links here as well. So feel free to just kind of go on there and use that as an open site as well. And if you have opinions on whether you like it, you don't like it, please let me know. We're just experimenting with this free stuff. One link I did want to bring to light, has everybody seen this BIM-related lawsuit article? Right? I just wanted to call some attention to it because I think, particularly with our speakers tonight, it's important to discuss what this really means. For those of you that might not be totally aware of what it is, it's basically, it was an article by Nadine Post. It was in Engineering News Record, and Architectural Record. And just to summarize it real quickly, an architect and an MEP engineer, they used BIM to coordinate a project. It's a, what do they call it, a life sciences building at a major university. I just grabbed a few quotes out of the article. They used BIM to coordinate a particularly tight ceiling plenum with all the services. But to make the stuff fit, it relied on a specific installation sequence that the design team didn't communicate with the builder. So the builder went ahead and built it without doing, I guess, their due diligence. Again, that's my inference, not, you know, in filling in the blanks that are in the article. Stuff didn't. They were about 70% done. They ran out of space. Didn't fit. So the contractor sued the owner sued the architect, and everybody got brought into the fray. Interestingly enough, the insurance company decided not to litigate it because they thought that any kind of a jury wouldn't understand the technical jargon and stuff that's related to 3D coordination and clash detection. You know, I guess we're preaching to the choir here, but I don't think it would be that hard to understand. So what happened? It was a huge settlement, millions of dollars, according to the article, shared in responsibility by the architect, the MEP engineer, and the builder. So without any further information, I think it's hard to, Mike, yeah, what?
Can I add a comment? I actually wrote a response to this at the NR, but the key thing here was that the architect got involved in means and methods and sequencing. And that was it. That was the judgment.
Yep.
The architect determined the sequencing, and now is liable for it.
The architect and the MEP engineer determined.
It said they put the parts in the model. But
Well, essentially,
But there were other articles about this, and there were articles about this in the
I read other posts, other articles by this journalist author,
Mhm.
and they all have this sort of negative.
Yes.
to them.
yes.
And if you read through, yeah, there was a lawsuit, and it does happen all the time, but it seemed more that the article kind of misstated what
It
the
did.
situation was, or emphasized the wrong parts of the situation.
Yeah, misstated. That's why I say here, read through all the comment threads in either one of the ENR.com or the archrecord.com website where the article is posted. There's probably 30, 40, 50 comments on each one that say that, you know, Nadine, you know, great author, great, but, you know, the last one that she posted was red lights to IPD adoption, you know, which is another one of the kind of alarmist articles. But, you know, it's an article. What can we learn from this? Proper communication. Architects should still not be really involved with means and methods. If they are, communicate that. Say, you know, we coordinated it, but it depends on you guys installing it. Right? It sounds like there was a lack of communication or collaboration in this process. So,
Would you agree that this is a tool, not a Bible?
a tool, not a Bible. How to define a Bible. I've heard tool, not a process. That's the first time I've heard tool and not a Bible.
This is a tool to you, but it doesn't mean that utilizing it doesn't mean that you can't. It doesn't leave it open to interpretation. It has to. You have to interpret it in the field.
Yeah, oh yeah, yeah.
There was a sentence in the article, and I think it was a quote of the insurance agent who represented the project, where he said the builder was not sophisticated enough to understand the data that they received.
Yeah. So
He said a lot. I mean, again, this is one person writing or saying it, so I don't know what's true and what isn't.
Right.
But that's true in every project, right? The builder interprets it one way, or doesn't have the knowledge or the skill to do it.
I'm going to try and sum this stuff up for our listeners online. We're saying, you know, it's not tool, not a Bible. Bible meaning that you can interpret the Bible in many ways. Thank you. Yes, and another comment from Robert about the, you know, in the article it said that the contractor wasn't sophisticated enough to, you know, and that was I won't elaborate on that sentence, but essentially it sounds like they're saying the builder wasn't sophisticated enough to understand doing 3D coordination and properly planning. Now, my takeaway from this, the implications are that proper project execution planning needs to happen. I'm working on the NBIMS committee right now where the Penn State execution planning guide has been submitted as a standard. It's going to, hopefully we're going to try and push it through in my work group and make that part of the national BIM standard. So that when you're doing a project according to NBIMS, you know, you'll have an execution guide. Question?
Yes. In this process, did they go through a standard shop floor process?
I'm going to assume that they did.
So why would
Again, it's a short article, not a lot of details. It's basically Nadine interviewing the one representative from the insurance company, from Excel. No other interviews, because the rest of the details are confidential. So we can't infer anything from this other than just remember that we, communicate, collaborate. That was the lessons that I'm not taking it as a, oh, we should stop doing BIM and stop doing coordination. No. We just need to make sure that we're doing it in the proper context. And then we'll have a whole huge presentation about this, about an MEP engineering company that is doing this and doing it well today. So hopefully, I just thought it wasn't getting them in here wasn't a direct result of the article. I just thought it was a funny coincidence that the article was out and we're having this kind of a presentation tonight, and I just wanted to open up for discussion. Great discussion. We could probably talk about this more afterwards. So keep those questions ready as we go through. Got your copies yet? Mastering is now shipping too, so all I don't know, like 6.5, 7 pounds of 2 books can be yours on a bargain basement price. Essentials is available on iBooks and Kindle. Mastering will be available on iBooks soon. I have the preview copy if you guys want to check it out. I don't have a copy of Mastering to give away tonight. I'm sorry. We'll try and do that at a future meeting. And again, I keep, probably I'm still in the midst of reading this one, but if you really want to know all about BIM and parametric modeling and case studies and the history of everything that is BIM, that's the book to get. Certainly get my books if you want to learn Revit, but if you want to learn the background and have the kind of depth of knowledge like Mike does, that's the handbook to have. Sorry, I'm picking on you. Upcoming events, Chicago BIM Forum, a highly recommended event if you have the funds or the means to get out to Chicago. Always a good thing. It's all about case studies, real people, real companies doing real work. It's in the middle of July in Chicago. It should be nice and toasty out there. And if you want to save $125, register before next week, before June 16th. So our upcoming meetings, we have just the stars have aligned, and we have some really great content for tonight and the next 2 meetings. Haven't fully booked in the next 2, but we're pretty confident. Everybody, I have email kind of saying yes, we can make that date. So it's the summer of engineering. We've always wanted to have a more of a focus on our engineering colleagues, having them come in and talk about how they're using BIM and how they're implementing Revit and other tools. So we're lucky enough at the very last minute to have Chad and Tommy come through. Through my good friend Arlene Hatfield at Buro Happold. So they're going to be talking about some great stuff. July is Thornton Tomasetti, and August should be JB&B. So stay tuned for some good stuff there. So let's get right to it. I'll introduce our guest speakers for tonight. Chad Konrad is a senior mechanical engineer at Buro Happold, and Tommy Taggart is a senior BIM technician. They're going to talk to you a little bit about how they started implementing BIM and the history of what they're doing, how they're doing, and we're focusing in on how they're doing model-based coordination with Revit and Navisworks. And we've talked about this subject in the past, but hopefully you'll see some real case study stuff here. Because it is, in my opinion, we've seen in the article, probably one of the most critical BIM uses that you can implement on a project is coordination. A lot of other good stuff, program validation, energy analysis, but this is really the one that that is one of the most critical things in making sure that your projects come out and you're starting to avoid change orders and things of that nature. So, without further ado, let's give a big round of applause for Chad and Tommy. Thanks.
Thank you very much, James. We're here this evening to present to you the Yale School of Management. Is this,
Let's do Control Tab. F5.
There we go. So, the Yale School of Management is we'll start with the objectives. So this evening we'd like to talk to you about our experience using Revit MEP 2010. We used the program over last fall and early this spring to coordinate the Yale School of Management project. Our goal this evening is to tell you more about the process, the pitfalls, the pain involved in the experience. So the School of Management is in New Haven, Connecticut. It's on the main campus. There was a whole lot of negotiations involved to get the site. The site is quite large. The building itself is 250,000 square feet, so it's not a small building. What you see here is the front of the building. On the left side here, this is a classroom, 2 classrooms actually, and here we have a couple more classrooms. This is what they call the feature stair. He has a similar feature stair over here, and then this is the library. These are the marquee spaces for the building. The design architect is Foster & Partners. The architect of record, Grusin Santon, and as I said, it's quite a large building and has a sizable budget, and we're really excited to be involved in the project. Buro Happold provided structural, mechanical, electrical, plumbing, fire protection, LEED, and energy modeling for this project. And our goal is LEED Silver, but it remains to be seen whether or not silver is achievable. Most likely silver, hopefully gold. This is the building as a whole. This is the first floor, but this is the second floor, but it's roughly typical for the spaces in the building. This is the main street right here, and the entrance that the earlier shot that we were seeing is coming in on this main entranceway right here, where the library, this is the space here is the library, and we have 16 classrooms in the building, 8 at the north, stacked on top of each other, and 8 at the south. And then on the right side here is the Beinecke room, which is the meeting space. It's kind of a conference, or it can also be reconfigured into a dining room. On the south side of the building, we have here a lot of admin space. So you'll have professor offices, admissions, the dean of the School of Management. There's all sorts of uses in here. And what you'll also see is that this little portion right here is actually an atrium. So this is a 5-story atrium. On the south side, we have 5 floors. On the classroom level, we have, on this classroom area here, there are only 2 floors, floors 2 and 4. And here we have a similar setup, 2 and 4 classrooms. The center of the building here, this green space, is actually, this is an outdoor space. So the building is roughly, it has very thin bridges that connect north to south. And off of those bridges, you have the library spaces in the Beinecke room and whatnot. So this shows the circulation space. So right now we're standing on the either north or south side, I can't be sure, but anyway, you see that the facade on the courtyard is curved, and it's actually faceted, but the facets are gentle enough to where it gives a curved appearance. And you can see the planted courtyard, and what we have on the right side are the blue banding. Within the blue banding are the classrooms. So we designed this job in AutoCAD through DD, and at the end of DD, Yale facilities had heard of this program, Revit, and they were really excited about it, and they asked if we could do it. And I personally was really excited to do it because I had used Revit 2008, 2009 to do a school project here in the city, and anything that I can do to keep myself in the program, I'm really excited about. So we began this job in MEP 2009 and upgraded it to 2010, but subsequent upgrades we didn't do just because it was close enough to the end of life of the model to where we didn't want to have to figure out if it would be a problem to go to 2011. So this model is still in 2010. What you see here is the architectural model, which is a very high quality model. It's very lightweight. It's only about 100 megabytes. So they did a very good job of keeping it to a manageable size without having, excess information or big heavy families in the model. We also have here the structural model, which you see similar shots, only steel. Here is the other side of the building. And then this is the mechanical model. The mechanical systems in this building are chilled beams, radiant floor, displacement ventilation. We have dual wheel heat recovery units, so we got to use a lot of really high-end systems in this building. And our plant space is all in the basement. So the School of what you see here is all 5 floors, but we have also 2 underground levels. The first underground level is where all the plant rooms are, the incoming services from the Yale Central Plant, and the parking garage. So mostly underground space is parking garage. There's a little bit of program down there, but for the most part, that's where all of my things are. So what you see here in the salmon color, those are the outdoor air handlers, and all of the magenta is ductwork. So I do the majority of my horizontal distribution in the lower level, which means that all of my vertical distribution is achieved only in the designated spots that Foster's intended. Because if you look at this particular rendering, you see that what they intended for the building is for it to be very transparent, with the exception of those blue banded classrooms. So all of the horizontal distribution is done underneath that green courtyard there, and then once I rise, I have to keep going straight up to the spaces. So all of my local risers are contained within those blue banded classrooms. So it's essentially an exterior sheath and then an interior acoustically valuable wall, and between the two is where my MEP stuff lies. So the model, the mechanical model, is here you see the on the right side, what you see is the atrium, where I have 5 floors of atrium. We have smoke exhaust at the top for fire situation. And on the left, bottom left, is the courtyard. And then the top left is one of the corridors in the building. So if you strip away all of the elements except for the plumbing, what you see is this particular image, where we have the bathrooms mostly stacked. There's a lot of pipes in here. This encompasses all of your roof drainage, as you can see from all of the high-level horizontal pipes that then collect and run down. Down here are all the incoming services. So, as well as the plumbing, we have a fire protection model where we ended up modeling all of the branch lines, as well as all the sprinkler heads, all the mains, the incoming services, the fire, the dual fire connections to the primary service, the secondary service. It's all in the model. Everything's in the model. This is the mechanical piping. This knot down here in the bottom center is the incoming service room. So if you look really hard, you can see my steam pressure reducing valve station right here. And then from here, I turn steam into hot water for heating. And we have chilled water incoming here as well that we use for cooling. This is the ductwork in the building. As you can see, there's quite a bit of it. And then if you put it all together, you get something like this. So, as I said, we really went for it with this model. We got pretty much everything that you can think of in here. But that's only half the story. As we'll see in a moment here, we have a walkthrough. Let's see. Do I double click on this? Yeah. Maybe we'll come back to this later. But anyway, you run around the building. So, our learning objectives for the evening. Objective number 1, how do you coordinate the systems? Well, it's no real mystery. You rearrange stuff until it doesn't hit each other. So that's not too big of there's no real revolution here, other than what we quickly learned is that this is not the first time that we've used the program. We used it on this other school. This is my 3rd model, and I consider it to be my masterpiece so far. But still, you know, if I could go back, there are a few things I would change. But still, I'm really proud of the model. But what we didn't realize when we were putting in all the content that you saw on the previous slides is that when you work in CAD, it's really easy. I guess I don't have to tell you guys this, but just in case. When you work in CAD, you can lay out an entire floor of ductwork and move on. And then coordination is something that in most cases, if you don't perform it, sometimes it comes back to haunt you, sometimes not. But in this particular building, we had to add a floor because they didn't have enough program space. So when they added a 5th floor to that south block, our 2'6" mechanical zone became a 1'6" mechanical zone. So when we began to export to Navis and start to clash these models, we realized that we hadn't sufficiently modified the way that we designed, and we hadn't coordinated as we went. And so we made the process much, much more difficult than it could have been. So the objective is coordinate as you go. You'll be doing yourself a favor. And then the other objective that I'd like to introduce is policing of the model. And this is something that I learned when I was given additional resource to hit a deadline. Let's say, you get this guy for the next 3 weeks, have him help you out in the model. So you get somebody who's never worked in the program before, and they treat it like AutoCAD, so where they do what I said. They lay out the ductwork that you tell them to, and then you go in there, you find it's on the wrong work set, they're using the wrong diffusers, the flows don't add up, they're not using systems. There's a whole bunch of pitfalls in modeling. Again, I don't have to tell you about them, but policing the model is a very, very important part of getting to 0. Objective number 2, the pros and cons, again, there are many, but related to the coordination of this particular building. As I said before, I don't have a whole lot of horizontal distribution above the grade level because they want a very transparent building. So that means that all my horizontal distribution at the lower level is extremely tight. And I have to say that this fact, coupled with the fact that they added a floor to the building, means that I really do believe that without Revit, this project wouldn't be buildable. It's just too tight. It's too tight. And so for that reason, this program facilitated this building to actually, be built. Again, you can know the tight spots while you can still do something about them in design, because the clash detection process tells you you have a real hot spot here. You need to do something. You need to figure out what's going on, reconsider the way that you want to serve this sort of area. The pitfalls that we ran into on this project were mostly time related. In November, we had a coordination meeting, and we began to look at these clashes, and we had literally tens of thousands of clashes, and it was horrific to go into this meeting where the owner is attending, and he's freaking out. We're really concerned, because we didn't think that we did a bad job, but when you see literally 30,000 clashes, it's disconcerting. So in order to get that giant number down, you need to put a lot of investment in time into this model. And it's not just the time to resolve 30,000 clashes. It's to take these 30,000 clashes and get it down to a number that's more manageable, that's more realistic, which is what Tommy will talk to you about in a minute. Also, when we began this process, we hadn't ever tried to coordinate to this level in this program. So we didn't know what sort of promises we should be making to the Yale facilities department. And as the owner, they were, on one of the first slides I showed you the scope of the building. And since most of the building, the entire building except for the architecture was Buro Happold. So there's not many people that we can blame for the perceived lack of coordination when you see a number of 30,000. So managing the client's expectations and really getting him aware of what he's going to see when the coordination process begins is very, very important. Objective 3. The process is what we're going to focus on this evening, and I hope you guys are ready to get down into the nitty-gritty, because Tommy's going to show you some pretty some pretty good Navis tips. Who do you want at your coordination meetings? It's no surprise that who you want at the meeting are the people that are actually going to be doing the work. So myself and people that are not necessarily at associate level, but more of the engineer level. Maybe even the graduate engineers, because if those are the people who drew the ductwork, they're the ones that are going to say, oh, I know this area. This is mine. Let me take this one. Let's move on. Because one of the first things that you do is when you have 30,000 clashes, to go through them one by one, you're never going to make it. So as an example, I have this slide here with a picture, and this particular clash was on the 4th floor bridge, and Stephen, the structural engineer, we saw this come up at one of the very, very last coordination meetings, and from this picture, we had to figure out where it was, and we knew that it was on level 4. We know that we're looking north, which means we're on the west side of the building, because I know that this ductwork is at below the bridge. And for that reason, we were the right people to be at the meeting. We can say, look, I know where this clash is. It's not a big deal. This is actually a architecturally rated wall that needs to get moved out 6 inches. Not a BH clash. This is a Gruz and Sampson clash. It's you. So we can move on. So we didn't spend 5 minutes figuring out where it was, what it is, whose responsibility it is, whatever. The meetings themselves began in November, as I said, and at first the process was not very straightforward. It began by us uploading a Revit model on Friday, and then the clash detection consultant, because this is not something that we thought that we needed to be involved with. We thought, you know, we'll give you the model, you guys clash it, we'll show up, we'll look at the clashes, we'll fix the stuff that's ours, you guys fix what's yours, and then we'll be done. So we show up we give them the model on Friday. On Monday, the clash detection consultant, he's one guy, he's stationed in Connecticut, he has a laptop, and that's it. It's one guy with a laptop. So he takes these models and he has to open 56 3D views, export 56 Navisworks files, compile them into an NWF, clash them, vet them. The guy has never seen the building before, so it takes him an entire day to start vetting the clashes. And then of those, you know, several thousand clashes, he'll pick a handful that he feels like are a big deal, and then Thursday, we show up to the site in New Haven, and we look through the clashes. And it takes us an entire day to go through each one individually, assign blame, figure out who's going to fix it, and then go away. So and then Friday, we get back to because, you know, you go to New Haven, that's your whole day. So Friday, you come to work, and you have about 5 or 6 hours before you have to re-upload the model to get reclashed again. How much work can you do in 5 or 6 hours when you have 30,000 clashes? You can't. So we started looking for ways that we can make this better. And like I said, since he's one guy with a laptop, the most of his time is spent opening the 3D view on his laptop, exporting it, opening the next one, exporting it. So we're like, look, we've got 5 guys working on this project. Each one of us has a computer. We can all get in the model separately. We'll export the Navisworks view. That shaved the day off the process immediately, just giving him Navis files to work with instead of a Revit model. So now, Monday, he clashes, Tuesday he vets, Wednesday we go to the meeting in New Haven, we work Thursday, half of Friday upload, right? So that's not too bad, but we could get better. So Friday, we give him Navisworks. We leaned on him a lot to clash it in one day and vet it in one day. So now we have Tuesday, we go up to site and we receive the clashes. Now we have Wednesday, Thursday to meet. So what do? We try and get another day out of him. And we do the meetings by web. Saves cost, save money, right? Save time. It's great. But the final process that we ended up with was, look, we don't actually need this guy to do the clashes. If we're doing the exporting and we're doing the work, why don't we also just vet it? So we learned that at first we weren't really interested in being the controlling party of the clash detection process, but it was in our own best interest to do it because the whole job is Buro Happold except for the architecture. All the clashes, I mean, 85% of the clashes had to be resolved on our end because Reason Sampton's not going to drop the ceiling height. They're going to tell you to make it fit. So we said, look, all right, we're going to do this in-house. And so now we have Monday, we clash in the morning, we do the WebEx in the afternoon, and then we have all week to work on this. So this is the final process that we ended up with. And Tommy wasn't aware of the first few iterations of the process because this final process was his job. So Tommy, why don't you tell us more about that?
Good evening. So I'm going to tell you a little bit more detail about how we used Navisworks alongside Revit to get the best out of it and to look at that 30,000 figure and dramatically reduce it. Because as Chad has kind of pointed out, I mean, when you've got 30,000 clashes, it's pretty important to understand that a good, I don't know what percentage, but somewhere in like near 90 are false or inherent. They're not anything that you need to necessarily worry about.
Tommy, let me interrupt you for a second. Let's take a look at this question. Ouch is right. All right, sorry.
Question there. So anyway, what we're going to do now is when I came along, it was a little late into, it was when the madness to try and get these clash numbers to 0 was in full swing. And the instruction was, you know, look at Navisworks again, look at how we're using it, and look at Revit and find a better way, because if we run one more clash set and get a, you know, a figure that's in the thousands, we are going to be killed, literally. So we had to make sure that we didn't see any more like 5 figures. So what I'll do first is just run through some very fundamental aspects of Revit and Navis that I'm sure a lot of people in the room will probably be familiar with from past events such as this, or so I'm told. So within Revit, as Chad pointed out, a lot of time is taken up getting Revit to Navis, which is just an export process. So the work really starts there. You need to set up an export view. You need to make sure that that view is in good shape so that when it goes to Navis, it only has what you want to see, because, you know, if you're going to clash a duct model off a pipe model and there's stuff on either one that should not be there, it's going to produce clashes. So accuracy at export it's absolutely critical. So a good view template that is very, very specific and pretty strict on what it controls, you need to run that every time before you do the export, and then let the exports go. Now, the exports can take time. We spend a lot of time like cranking up 3 or 4 machines side by side just trying to get these exports done. So never ever underestimate part 1, the export process, believe me. Revit's able to export directly to Navisworks through a plugin that it comes with. You have to, I don't know if it's still a plugin. In maybe 2012 or 13 it might be involved in it, I don't know, but at this point it's a plugin and you have to install it. But once it's installed, you just simply export it. Again, just a reminder to account for the time that this takes. So when we export out to an NWC file. So I'll just jump ahead a little bit because I think I have an explanation back here. Where is it? No, it's not. So we directly export out to an NWC file. Now, how we create our folder structures internally for clash detection is we take those NWCs, like for instance, we'd export the ductwork in one NWC, the pipe in another, then we bring them together in an NWF file, kind of like XREFs within AutoCAD or whatever. So all you ever do is you create a folder structure on your server, kind of similar to this guy here, where you've got the different levels, and inside there's a master folder, just where you store your NWF, and then alongside that is what I've called an XREFs folder. It simply contains the exports directly. They go right there. Once you set this up once, all you ever do is export and overwrite the guys in the NWC, and your NWF file is automatically updated with the latest model, and it's ready to reclash. So that's when the fun begins. So kind of a similar setup to CAD. You can create a directory that you can really just overwrite, and it's very straightforward and simple. So that was pretty important. this is just I'm going to just kind of show you guys typically what we would be seeing on our screens most time when we're trying to get into the clash detection. So we usually have 2 monitors in the office, as I'm sure everybody does these days. On one of them, we would have the working sort of side where you would go root out the clashes and typically look at a little something like that. And on the other side would be this. If you're anyway serious about clash detection in Revit, every one of these menus here are critical. The first one we see on the left-hand side is the clash detective itself. This is where you set up what you want to clash. You apply to it rules, tolerances, all sorts of conditions, which is really what we started to introduce at this point in the project was rules and tolerances, and that's basically I guess the heart of this discussion here today is how to get your requirements into Navisworks, how to tell Navisworks to reach into the Revit model, pull out what you want it to pull out, and do things to it. So that's where we had to get quite heavily involved once we undertook to do the clash detection ourselves and get those numbers down. So we'll talk about these menus separately in some more detail, but this just gives you an idea of your sort of interface as you're clashing. This guy here is the simple selection tree where you have various tabs that show you the different Revit models, and in what's important for us in here, one of the tabs is properties, where you can go straight down to element and it digs into the various parameters in your Revit model and enables you to select them directly. So this guy was very crucial to interact with this guy, and we'll go into some detail on that. This is a menu that shows sets, which is basically when you pull elements out of Revit and combine them into a group that you want Navis to treat differently to anything else, it becomes a set. So that menu there was pretty important. And down here you simply see the properties menu, which every now and then you want to click on an element in Navis and see what size pipe it is or what system it's on, etc., etc. So that was kind of the working, sort of the look that you needed as you went. The first tab that I showed you guys a second ago is the Clash Detective Batch tab. This is where it begins, essentially. This is when, once you've exported and you're all set up and you've got your Navisworks NWF sort of master file ready with maybe 5 or 6 exported files loaded in there, ducts, pipes, architecture, structure, OCP, fire protection, all that stuff. Once they're all sitting in there and they're ready, you've essentially got to go to work in this Navis NWF file and really start to set the thing up correctly. Your work begins here. What you see here is what we call batches. So here's where you kind of decide what you're going to clash. So on the sort of blow above it here, you can see that one of the first ones we did here, what I can show you here, was the hot water service here versus the fire protection. So you literally set that up and you name it and you tell it that that's the, for this individual clash, that's where we're going to start. Now once you've done that, you need to follow through the remaining tabs to give that individual clash various sets of sort of properties, rules, tolerances, etc., which we will go into. So this is a rather full one. This is from one of the significantly large master files we had when the project was at its most insane. So you can see that there's a serious, I think we clashed everything against everything for this particular floor here. So NWF files, your master file for clashing, it can be done by floor. You can be brave and do the whole building if you want, but probably not advisable. The NWC files, once you export them, I should say, they come out around 2 to 5 megs. So, but once you put them into the NWF file, that's a tiny file. It just brings them in like an XREF, as I say. So it's a very, you keep it nice and light when you're doing your work within Navis. So it's pretty cool like that.
The NWF file really just for the settings, right? Yeah,
an NWF file is where you bring all the exports in, and then you start to mess with them. You start to use Navisworks individual sort of procedures and settings to reach into those NWCs and start doing stuff with them and clashing them against each other. So in a sense, it's kind of like a holder for all the files that once you overwrite the NWCs and export it, they auto update in your NWF, and you can always keep it current. So it's kind of the heart of the clash detection process, the NWF file. We did have a slide in here explaining the file types, but it seems to have gone. I bet you I'll come across it halfway through the thing, but if I do, I'll talk to you about it. But NWF, yes, the master file where the work takes place. NWC, you export directly from Revit, put it in your NWF, and there's one more, which is an NWD. NWD, we would just do a save as from the NWF. It's kind of like a photograph of the whole thing, like a PDF or a bound DWG, if you will. So if we needed to send these files for verification to anybody, we would just save as the NWF, save it as an NWD, and send it across. And it limits what people can do to it, essentially. It cuts off a lot of stuff. So So yeah, so you would start here, and as you can see, like there's a lot of clashes in here. I was just saying that, you know, you can choose to create an NWF by floor, by zone. You know, it depends how you want to clash. In this particular project, we clashed it by floor. So this here, I think it might have been level 1 or whatever it was. This appears to be pretty much the whole floor, every discipline against each discipline set in. So this is a pretty busy model, this one. One of the tabs further down is called the Select tab. It's in here where you get to pit one service against the next. So if we go back up a step, if you take one of these, for instance, the hot water versus the fire, when it comes down to this tab here, you would go to this area here and you would select your hot water model here and your fire model over here, and then Navisworks knows that these are the two models that you want to be clashed. So it's quite straightforward really in that regard. It's just simply where we get to define what's being clashed, and we also define tolerances in here, which is down the bottom, but we'll come to that in some detail later. This is kind of just a quick intro to some of the menus that we use. So once you've kind of set those very basic batches up where you say what you want to clash and then you sort of like preset one model versus another model, it's time to, you know, if you were to run the clash right there and then, which you could do, you're going to come out with a huge figure as we discovered. It's going to be inaccurate, it's not going to be much use to anybody, and you're going to waste a lot of time sweating over work that you don't have to do, and believe me, we learned this the hard way. So what you now need to introduce into your workflow are rules and tolerances. What do I mean by that? Well, if you think of rules, you want to tell, if for instance in Navisworks you have something that you know that you don't mind it clashing, and we know there's instances of that here and there, you need to give Navisworks a heads up on that. You need to say, look, if you come across this, don't report it because we don't want to know. So that's what...
A good example of that would be sprinkler heads. Unless the architect models a little round opening in the RCP to accommodate the sprinkler head, every sprinkler in the model, if it's in a ceiling, is going to come up as a clash. So that's the one you throw straight out. There you go, you just got 2,000 or 3,000 clashes on.
Yeah, absolutely.
Was that part of the 30,000?
Oh yeah.
Yeah, it's a large part. Yeah. So we you know, but once you see 4 figures going, you kind of get some hope, you know. So rules we'll expand upon greatly in a second. So yeah, so once we started to think in terms of let's put some rules in here and really, you know, because we were up against it, as Chad mentioned, an owner that was like staring down the barrel of like serious amount of clashes, and we needed to act fast, and we needed to really get this software to work for us, and to work hard for us, and you know, we did do it, but you know, understanding how it was a learning curve. But with rules, yeah, so rules pretty important. Tolerances are the other really critical thing, you know. You can model whatever you want in Revit, but you know, taking in regard, if you're going to work alongside a contractor or you're going to make a clash-free model, we all know that you've got things like fire rating and insulation, all sorts of stuff that you've got to deal with. So you need to tell Revit or Navis, you need to tell someone somewhere that this pipe is not just 2 inches, it's 4 inches because it has insulation. So sometimes, I don't think we modeled on this particular project, we didn't model the insulation for the pipe work. I mean, the insulation functionality in Revit 2010 isn't great. I think it's improved now. You can actually do it like for the whole model in one shot, but it used to be that you had to kind of do it as you go. So it was too late to really turn back, but it didn't really matter because you can control these things in Navis. So if you haven't got insulation on the Revit model, you can go into Navisworks and you can apply a tolerance that Navis understands that when it deals with this pipe in this particular system, it knows that don't clash it if it's, you know, a certain distance from the next object because of the insulation, or do clash it because it has no clearance even though it appears to. So rules and tolerances quickly became the order of the day, and we had to go fairly deep into that in order to accurately get these clash detection, sort of these numbers down. So looking at rules, this kind of is repeating a little bit about what we're saying, but I guess we need to emphasize it because it was absolutely horrible seeing those numbers. And I mean, when you think about it, the rules that you would want to tell Navis, an example would be, you know, we don't want to clash pipes that are 2 inches and below. We were lucky enough to work with a contractor on this job and have them by our side through this, and they agreed that, look, you know, we're not interested in those size pipes. We're just not. We'll do that on site. We'll find a way for them. They're too small. So straight away, we had to make sure that we told, you know, Navisworks to exclude any clash involving those pipes because they just didn't matter to us. Another thing would be light sources, the illuminants. In Revit lighting families have these illuminants. Like as we discovered later on, if you put a lighting model in, it clashes against those illuminances, and they can be pretty big. So our numbers went up again by another 5 figures at one point, and we soon realized that we had to get rid of those. Now, of course, you can go delete them in the Revit model, but why do that when someone might need them? So again, another rule we needed to tell Navis about, like, don't include those things because we don't want to know. And as demonstrated by this little picture here, I say at the end, like, there are some inherent clashes, such as a piece of flex duct going into a chill beam. Navisworks and Revit didn't really talk to each other too much about this because they thought that was a clash every time. And that's just one example. We have a few things that happen like that. It's not a clash, but of course it's being reported, and every time you run it, it keeps sending those numbers back up for you. So we also had to deal with a selection of inherent clashes that they're just not clashes. So we needed to figure out some rules that would deal with A, things that we know are clashing against each other and we don't want to know about, B, things that we know are clashing but they don't matter to us, stuff like that. So that's the kind of first thing to know about rules. This is just the basic rule dialog when you're in the Clash Detective tab, and you'll kind of see here that these are the rules we've created down the very bottom here. This first one says, if you look at the top, it's quite important. The rules are ignoring rules. So basically, that's the premise of this. Navisworks will let you tell it to ignore things. It doesn't really expand much more than that. But you don't really need more than that, as we found out. So the first rule you'll see that I have ticked there, which is items which are both in a selection set called chill beam flex duct. Now don't worry, I'm going to explain what that's all about. But basically, that's a rule. It's checked. So when I run that clash, it knows that ignore any items that are in that particular set that are A, a chill beam, or B, a flexi duct. And it just straight away drove the numbers way further down because it eliminated all those useless clashes, and you can't imagine how many of them we had. And the same thing for the light sources, all gone. So how do we add rules? Well, rules are created using sort of predefined selection sets and search sets. There's two ways to populate rules. Rules require, if you look at the picture here, so this is me starting a new rule, which is just clicking on this guy down here, and there's various rule templates available through Navisworks. The most common one we like to use was it's items which are on one selection set and items on this other one, ignore that. So that was probably one of the most useful rules for us. So as you can see, you've got these little areas here, these values that you need to enter. And this box here just demonstrates what those values, those choices are. Now, it's populated here with search sets and selection sets, which I'm going to explain now. So you have to create a set of elements. You have to lump some geometry together into a group in order to be able to populate these rules so that Navisworks is successfully able to understand what you're trying to tell it. So in creating a rule, it's a simple procedure where you just go new, you choose yourself a template. Is it going to be a template where you want to have one thing against another, or is it going to be a template where you want to have two things on one and tell it to ignore it? There's a lot of possibilities to go into with these templates here when you get into it. And then in order to populate the values in here, you just have to create your selection sets and search sets. So a set is a group of elements from the Revit model that can be isolated within Navisworks, simple as that. There are different ways to define these sets in Navisworks, both by selection and by searching, which we're going to go into. And most importantly down here, which we found out in which was probably one of the most painful lessons we learned on this, it's search sets that can be exported from one Navisworks file to the next. Selection sets don't work so well in that regard. So selection sets we'll deal with first. They both have pros and cons. So when we want to create a selection set in order to put it into a value in our rule set, or our rule as it were, first thing we do is we go to our selection tree, which is one of those menus I showed you at the beginning, which you would have open. You navigate to the Properties tab, and under the Properties tab there's a guy there called Element, and in here there's quite an extensive range of parameters available to you across the entire model. So if you have 5 models like lumped together in one NWF, you can go in here and you can pretty much pick out elements throughout all 5 models through this one tab here. So the range of parameters that can be picked up there are extensive. For the purpose of this, for clash detection, we mainly use such things as size, system names, the light sources, as I've mentioned, various pieces of equipment that we chose to isolate all those things. We chose to to tell Navisworks, you know, go into the Revit model, pick those guys out from the various models, and isolate them for us. So here you can see on the second one, I've gone down to element and I've gone to the size set here. And there you see all the selection of pipe sizes, elbows and fittings and various things that are available. So it's basically reporting back to me what the 5 models have brought to this NWF file, all the different sizes, and it's making them available to me for selection there. So that was useful when we needed to crack down on pipe sizing and stuff like that, which we'll go into. The other way we would have used something like this is for system name. So you can see under elements, again, it's just another category under here called system name. And these are the systems that we would have set up within the Revit model to do the mechanical engineering. I think there are most of them. So it became very important to us later on. We realized that not only did we need the ability to go into Navisworks and get it to look inside Revit and get us such parameters as, you know, sizes and equipment, sort of various, you know, things involved with the equipment that we wanted to isolate, but we found out that, you know, we needed more than that. We just couldn't have every 1-inch pipe in the entire model be on one set. We needed to break it down further. We needed to have every 1-inch chilled water pipe isolated, every 2-inch hot water pipe isolated, because each of these things required different insulation. There were different rules. Now we'll come to that in tolerances, but that just demonstrates the starting point for that. You can, provided you build your Revit MEP model correctly, provided you create systems correctly, provided you work logically, and your users know, which comes back to Chad's point about people not putting stuff. If someone worked for 2 days in this model and did a load of hot water and didn't put it on a system, we wouldn't pick it up in Navisworks, and its flashes would be completely ignored. So it goes back again to what Chad says, you know, policing the model, getting people to populate those systems and draw stuff properly so that we can catch it when it gets out the other end in Navisworks. Absolutely critical. So once you've got what you need, so here I've given an example of all 1-inch piping right up to 2, you simply select it in the selection tree under the Properties tab right down under Element. Now, the good thing about selection sets is you can select multiple parameters in all models. Now we'll see in search sets, and we do that next, that it's a little bit more limited, but with selection sets you can grab a whole bunch of them together. Then you simply go to your sets window, which is just another window that you can pull up through the interface. Right click, and then you see there that you've got 2 options, which is to add the current selection or add the current search. Now we're obviously doing selection sets, so that's the one you go for. And then it populates this area here. So you can see the various selection sets we created for use in this project. So we put, a lot of the time we'll just put the whole model on it because we want to get particular about an entire model. We'll just put it on a selection set. Or, as you can see here, we've broken it down to individual services for the purpose of tolerance. So those individual services would have come from where I showed you how we dug out the system name, where everything was drawn to a particular system, which is what Revit, thank God it does. So this is kind of really, really important. The basic premise of isolating stuff within Revit, pulling it into a specific group in Navisworks, storing it and naming it. Once you've got that far, then you can start to throw it into rules. Then you can start to apply some settings to it and make Navisworks think about what it's doing as opposed to just like clashing everything. So this, once you've got what you want, right click, do that, add it to there. This selection set is now defined and it will be available for use in the rule templates which we saw.
You're going to the properties tab, you're selecting those properties we created, say that as a selection. If you're adding stuff to the Revit model, pick it up.
Yeah.
Do stuff. I don't think so.
No, we found, yeah, well, no, it does. It did. We did not have to make those sets twice. No, because what that does, that's not selecting. That is, remember, that's going for it's going for the whole all of like all 1 inch, everything that's there. I don't think we didn't do selection sets more than once. We got it and we tested that, and it certainly seemed to capture everything every time. So if it had been the case that we added more 1 inch, 2 inch pipe work and it didn't pick it up, we would literally have had to create those sets like every time. So that didn't happen, and we got down to 0. So my guess is that yes, it picked them up. So I would understand if it was a specific part that you selected in there, but remember that parameter that we selected, all there, they're very broad. They're saying that 1 inch, it's picking anything that comes in that contains that specific value that will be under its umbrella. So that's what I imagine is the process there. Again, we didn't create these sets multiple times, so. All right, well, yeah, maybe it was the search sets where, yeah, I mean, because that's what I was kind of going to come on to. We started by using selection sets, and we soon learned that selection sets were not as valuable to us as search sets, because with search sets you had the ability to export. And I guess that if we shifted all our pipework onto these search sets, which we did after a while, I guess then we wouldn't have seen the problems. That's probably what the case was there. Selection sets is what we first discovered, and when the problem we found, the reason we switched from selection sets was that we just couldn't export them. We kept trying and they wouldn't. Because if you've got one NWF file and you need to create another and you need to use all your work that's put down already in terms of your sets and your rules, et cetera, you know, it was a bit of a nightmare to do a save as and repopulate and do all that kind of stuff. So we simply wanted to take them and export them and just load them into another file. And selection sets let us down really badly there. So we switched over at that point to search sets, which I'm going to talk a little bit about now. Search sets were a bit more limited because you had to search out one pipe size at a time. It didn't give you the same value to do greater than or less than. So that was kind of the issue we came across with search sets as well, is that we found it a little more limiting. It was good for some of the things we wanted, like if you wanted to pick up an individual, but when you were trying to say to something like give it a condition, we found it a bit limiting. So you had to, which I'll show you, I think I have an example of it, we had to tell it that it directly equaled 1 inch. We couldn't say that, can you pick up everything in this model that's 2 inch and down in one shot? We didn't find a way to do that. We did find a way through search sets to point it directly at a specific pipe size, and then to keep doing those pipe sizes until we uncovered everything we wanted and add all those conditions to the set. And that worked. It took a little longer, but I guess search sets just had a few more advantages that we thought were workable. So this is a basic screen on when we started to transfer to search sets. You can see down here that this is basically using the find items guide. So you'll select the model that you'll go search in. There's a basic sort of formula here with conditions, and again the same process. Go to your sets, right click, and add the guy in. Look at that a bit closer now. So this example here was when we first discovered search sets. It was trying to isolate the lighting illuminance sort of parameters in the Revit families. So through there we were able to go to the lighting model, and we're able to run the search through here with these sort of values in here, and then do a find all. You know, it pulls them all out, and then do the same process. And then you'll see that the search set has a different little icon down there. And then once we did that, we were able to export the thing. So it was at that point that it was quite early on in the process still at this point, but then we switched over to search sets and found them pretty usable. So that worked out real well for us. So you just have to navigate to the parameters you want to find items function. This searches through the selected models for available parameters. Now, I don't know if anyone else knows the way, but the advantage we found with using selection sets was we could do much more of a broader search. We could cover more ground. With this, it was a little more limited to extract the information we wanted. You have to put a little more time in, but I mean, it paid off in the end. Because with selection sets, again, you can select like so many things in one shot and then push it through like 5 or 6 models, and then it will take everything out of those guys. But in the search sets, it was a little bit more limited. We found in terms of the especially this equals function here when it came to pipes. As I said, it didn't give us the option when we got through the item and down to the size parameter. It just wasn't available for us to say that equals to or less than. So we had to individually add them in with the equal sign. So I don't know, there might be an easier way to do that, but that's the way we kind of got it done, and it worked out pretty well. This is an example of using your sets. I mean, there's many ways to use them within the rules, but these are the 2 main ways we use them. One is by quite simply, you know, setting one set off against the other and just saying, you know, ignore anything on this, ignore anything on that. Example would be, you know, ignore any sort of 2-inch pipework and below against the architectural model, pure and simple. Don't report any of that back. Another useful function we found out of using the rules was by using this other template, which enabled you to put 2 things on one set and then tell Revit to ignore, or tell Navisworks to completely ignore everything on that one set. And that's how we figured out to do the flex duct into the chill beam. So you can see here we just went around, in this particular case, just grabbed them, threw them on, and then I created that rule. And then anything that was hooked into there was completely ignored from then on in. So that worked out pretty well. So in terms of, that's the most I can tell you really about how we did with rules. We kind of got very deeply involved with the selection sets, the search set, populating the rules, understanding what rules were workable, what weren't. And it took the clash numbers down. I can't tell you how much it took them down. Like it was unbelievable. So once we got that far, we figured, you know, that there must be further to go. And the next thing we moved on to in conversation with the contractors was tolerances. We stopped and had a conversation about, you know, what tolerances are they going to use when they're building? What insulations are going to be, you know, in this model? What is the fire rating? What distances, you know, what's allowed, what's not allowed? What can we do? Because, you know, some of these spaces were getting really tight, and Navis was reporting a lot of stuff, and we wondered, you know, maybe we can reduce these by, you know, adding in some tolerances or telling Navisworks that this is okay if it's clashing like this or whatever. So in understanding tolerances in the role in clash detection was really essential as well, just as important as the rules. So tolerances inputs, you know, they'll vary on the objects being clashed, pipes and duct tolerances, each other and stuff like that with various insulation. So you'll find that pipes versus ducts is going to be different than pipes versus steel, et cetera, et cetera. Tolerance inputs, they'll even vary depending on what system the object is associated with. So hot water versus structure and fire protection versus lights. I mean, that's where I was kind of going back to everything getting on the right system so we can go in and snag it out of the Revit model and make sure we pick it up for tolerance purposes. So again, back to drawing your stuff in Revit absolutely correctly so Navis can reach in and grab it through the, you know, the search set or selection set, and then we can start to work with that individual sort of set of elements and give them unique tolerances. And obviously tolerances should reflect industry standards and be agreed with the contractors. We were in a good place with this because we could sit down with the contractors and say, look, here's what we think the tolerances should be. What do you guys think about that? And they were able to, you know, have meetings with us and sign off on exactly what we agreed. Navisworks would clash and not clash. I know Chad is pretty heavily involved in this, in setting these tolerances up. Well, it was Chad. We initially sat down and had a conversation and decided on, I guess it was important to think about what ducts, like obviously certain ducts are not going to have the insulation. Certain pipes didn't have it in the Revit model, so we had to put the, I mean, obviously if the insulation is on in the Revit model, it changes things a little, but we didn't have it, so we had to look to Navisworks to understand these sort of spatial requirements, right?
So at this point, Tommy had done a lot of work in learning how to use Navisworks, and the clashes came down very dramatically, but one thing that we had a problem with the outside clash consultant is that he was using a value of 3 as his tolerance. So anything that was within 3 inches of anything else came up as a clash. So if you had, for example, something like let's take the example of fire protection versus lights. So if you had a fire protection pipe within 3 inches of a light, it would come up as a clash. But there's no reason for that to be a clash because the fire protection pipe isn't insulated. The light has no cover on it except for the cover that's modeled. So we threw away a lot of clashes by adjusting the tolerances per set clashed against each other. And as Tommy said, the pipe isn't just pipe in this particular model in the sense that all the pipe is modeled without insulation. So hot water is required to have 2 inches as opposed to chill water, which is just 1 inch. So using the systems, we were able to vary the tolerance per the things that were being clashed with each other. So we presented this list to our contractor, and then anything that is smaller than this tolerance becomes a clash. So you'll see that some of them are 0, and we were very, very fortunate that the contractor went along with these numbers because typically they're like, yeah, well, you know, I want to be able to get my knuckles back there or something. And we expressed them, look, we all know that having more than 0 clashes means that we need to start looking at these clashes. The review of the clashes themselves takes time. Let's just focus on things that are really hitting each other. So only if 2 objects overlap and attempt to occupy the same space, that's a clash. 2 things not being knuckle distance apart doesn't count. Let's just, you know, do the best we can with real clashes, and they went along with it. So we that gave us the extra help to get to a number that was close to 0, since, you know, we didn't actually get to 0.
So yeah, tolerances proved to be the next step along the way in reducing this dramatic number that we started out with right down. So this was just an example really of some of the figures we agreed upon. You know, the structure, as Chad pointed out, the model is not going to have the fire rating on it, so we knew we need to allow for an inch there. And if it was being clashed against something like hot water, we knew we had a 2-inch there, so therefore our tolerance in that regard had to be 3 inches. So next up we see adding tolerances to these particular searches and clash detections. Once all tolerances can be have been agreed, we begin to add them to the clash protection process. So here you see again back to this clash detective window, and under the select thing where I showed you earlier, where now we have the options to pit, various, like down the bottom here, you'll see where you can either pit your straight up models or go back to your search stroke selection sets and sort of pit them against each other. So you've got a large range of options here when it comes to what you want to, how you want to go about clashing and how you what against what. So you need to front end this. I mean, I guess that's the whole point here. We found out halfway through this that you really need to front end this very carefully by creating those selection sets, those search sets, populating those rules, inputting those tolerances, agreeing those tolerances, getting the right people around the table. Because you're trying to secure that when you come down to your result, you want it to be reliable. You want to have people involved along the way that can see your process. You want to keep it open. And as your numbers start to go down, you're going to give the rest of the team a lot of confidence, a lot of faith, and take a lot of the pressure off as you try and get these clashes down. So with the tolerances, if you see down the bottom here, when choosing to pit something against something, it's there you get the opportunity in a particular batch, particular sort of clash detection set that you can put in that tolerance, and then Navisworks will then understand that there's a spatial awareness issue that needs to happen in this particular clash when you go and do it. So we were trying dramatically to make any clash that came before us a legitimate clash, to make sure that if it even is a spatial clash, we wanted to see stuff that would restrict access, not just stuff that was piled into each other. We had to go both ways with that. So we found this tool quite useful in aiding us to kind of get a good feel for how accurate our model was coming along. So combining the tolerances and the rules function and kind of getting to know them and getting a team of people kind of up to speed with how to use these functionalities really helped us completely. Once we got, I guess, to the home stretch of this process, we had so many rules, so many sets, such a great setup going, and all the tolerances input in there that we started for the first time in probably the whole process to see a real difference at every clash detection meeting. When you hit that dreaded update button and it redoes the figures and they come out higher than you started, it's always disheartening to say the least. So when we started to get these rules in and tolerances in, et cetera, we really started to see the update give us lower figures every time, and it just meant that what that means essentially is what you're being presented with, what clash is being put in front of you is a legitimate clash. So when you fix it, you're taking away. Whereas before, when we had all these inherent clashes and these things that didn't matter, you weren't always fixing stuff that mattered. So there was a couple of great advantages to be had, and probably the most is that it gets you to where you need to be by eliminating the stuff that's not important. And once you start clearing those major clashes and draining out the unimportant stuff, you really start to see numbers go down and everybody gets pretty happy. So this is the sort of an example of one of the final tabs in the clash detection window, which is the results tab. This is always where the nightmares really began. So all the clashes that, as you can see here, we've got a few examples of the different types of clashes that Navis will report. So they color code them, they number them. They'll also give you a distance. Sometimes it'll be a minus, sometimes it won't. So you can get a feel. Like sometimes, for instance, that distance became critical because sometimes you would see that distance was minus 0.000003, and you would see maybe 50, 60 clashes with that number. So you knew straight away that could probably be taken straight out. So we tried to pay attention to that as much as anything else. So the first, so if you take it that we've just reran a fresh clash on a model, you'll see these first batch of results here would be reported back to us as new. So these are clashes essentially that Navisworks hasn't seen before. So people have been working in the model, people have been doing a lot of stuff in the interim. So it's saying, right, we've got a whole bunch of new stuff for you guys to look at. So that's what they are. Next ones are active ones, so I guess ones that are still ongoing within the project, ones that have not been resolved. So it will change their status to active from new once you rerun it. So it helps you to categorize and sort of to keep stuff, to keep track of what you've got without repeating yourself. And of course, once you go and fix something, and you rerun it and it takes a look at it, it's going to come back as a resolved clash. So the results thing was pretty critical. We needed to be heavily involved with this guy here and go through. As you click on each clash, it will pull it up on the Navisworks will automatically pull it up on the screen for you, and you can take you right to it. The only problem we had, which I don't know if Chad mentioned earlier, was with the lack of this switchback functionality. What I mean by that is, when we went to a clash in Navisworks, it could take someone a long time to find that clash back in the Revit model. Because I think, though, with 2012, or at least with 2013, that Autodesk have developed a sort of a successful switchback functionality that enables you to go straight from one to the other without having to waste time running around your model. Because if someone's not familiar with the model, it can take a long time to get up to speed on the various areas and where the clashes are. And we found that that was actually one of the things that slowed us down quite a lot. Because as deadlines approach, we need to get more people on this. And, you know, for them to see a clash in Navisworks and have to go and get to it themselves in Revit it was a bit time consuming. So that's been developed for 2013, so that will make it even faster. So that's a quick look there at the results tab. Also in the results tab, what we found useful to do was to create some folders to keep track of our clashes, because what you can do is you can take these individual clashes and simply drag and drop them and control, you know, where they exist in the whole browser thing. So we came up with a system that really helped us to get through this. So if there was a certain group of clashes that we knew were like a known issue, we had a lot of linear diffuser issues that were, you know, going crazy with the ceiling plan, and some of them needed to be moved, some of them didn't, some of them were inherent, some of them didn't matter, some of them were just Revit placeholders that were being clashed. So, but we couldn't just create a rule to eliminate them, because we needed the architect to just take a quick look at most of them to determine, you know, in some cases whether they were real clashes or not. So in an instance like that, we would just create a designated folder and drop them in there. So when you come to your meeting and you've got the team around the table, you can go straight to the first topic, which if you want to go through is that, and all your clashes will be in there for you. We'd always have an inherent folder to store the clashes that keep coming back as clashes, but we know they don't matter. So they'll be active, but they'll be in there, and we know that they can be ignored. So we would throw them in a folder there. A resolve folder, obviously for stuff that Navisworks has reported back to us as being resolved. It turns it yellow and it goes straight in there. And finally, we found a category C folder really useful. We classified this as stuff that was definitely a clash, but whose responsibility we were not sure. So all those clashes would be deposited in that folder, and then when you sit down to your meeting with the architect, with the contractor, we open that folder and we go through it, and we have a very open discussion about whose responsibility will be to resolve that clash. So towards, you know, coming up to a meeting, we would hit the update button. We would generate a new sort of bunch of clashes here. We would hopefully get a lot of resolves reported back. We would still obviously see some active because work was ongoing, and unfortunately a lot of time we would see a lot of new ones. So once that happens, we quickly went about vetting them, either picking out the inherent ones, dumping them in the correct folder, picking out the resolved ones, putting them in the correct folder, picking out the ones we feel that we wanted to discuss further, putting them in the correct folder, and then if there were any specific issues that needed their own folder, they would go in there. So when we went into a meeting, we would go in with something that looked like that. And we found that that kept it real simple, quite straightforward, and enabled us to get through meetings really quickly, and for everybody to be quite, you know, crystal clear on what we were trying to tell them about, and you know, got us around the model very quickly as well, and kept things quite structured in meetings, which was a huge help. You can also run a report out, obviously. I think most people might know about this one anyway. From once you're done, there are people obviously that don't have the software. There are people that want to read stuff on, you know, from paper or on their computers without Navisworks, without any of the associated, you know, models or whatever. So you can run out, there's various settings you can run out. You can limit it to active clashes or resolve clashes. You can categorize it and mess around, kind of like Revit scheduling. You can give it a lot of sort of settings that will produce a sort of a tailored report for whatever it is the person would like to read or wants on their desk on Monday morning to see what you've been up to. So that was, we used that from time to time as well. So that was another cool function. Finally, we found as we approached zero, as we started to get the numbers down into the figures you can see in this column here, things got a little confusing, because when you think about it, you're going through these Navisworks models. You have various people running clashes. I mean, we usually limit the people that did the update, the vetting, the categorization, the rule creation and maintenance. That would obviously be left down to a team of 1 or 2 people. But ultimately, you know, when it was really hitting the fan and we needed to get the clash numbers down, we needed to have a few people on this. So as the numbers got lower, we developed a sort of a tracking system of sorts where, you know, we would have the level, the particular clash that we were concerned about, and we would look at the numbers of clashes left. We would confirm whether the clash had been rerun. We would update those numbers. The category C's we would put in there, and we would sometimes have to put notes beside them because they were ones we wanted to discuss. So once the levels started to come down to reasonable numbers, we found that coming up with some sort of, and we'll probably develop this further, it was really our first go at it, but some sort of tracking system where you can put an individual's initials by the work they've done, so you know straight away who's looking after a particular set of clashes, whose name is next, because obviously if clashes report back about a certain area of the building, you know that there might be one engineer that deals exclusively with that area of the building, so he's going to have to look at that. So we would just go in, run the thing, vet it, find out where those clashes were, fill this guy out, and just simply put his initials next to it, send it off to him. Straight away, the engineer from here knew which clash set he needed to go into. He knew, basically, he was familiar with the folder, so he'd be able to tell, like, if it was a C, he would go straight to the C folder, and there would be a note left here by one of us guys to tell him that we couldn't resolve it ourselves, or someone's made a phone call, we can't do what we thought we could do, can you look at this again? So we probably will develop this to be a little more sophisticated, but that was a really, really important step along the way as well, as we started to really bring this thing home, was to track all the work we've been doing and allocate individuals and make them aware of where their work was within all these massive NWF files. So that was very helpful to us. I think about nearly, unless you want to say anything, Chad.
I just wanted to, I don't know if you guys noticed, but on the first slide, 0 was in quotations because, of course, we never actually got to 0. We were very, very lucky to have a contractor involved who, in the meetings, we would drag it into the C folder, C meaning I need assistance with this clash. It's a topic of discussion. And we'd show them a clash and say, look, I know I can add 2 elbows to this to resolve this, but there's plenty of room above that duct. I'm just going to ask you to clear it. And be like, yeah, clear it. So there are still clashes in the model. We didn't make 0, but we have contractor sign-off, and the contractor has accepted the BIM models and is confident that he can execute the project. So for that reason, we're declaring victory.
How much time did it take you guys to, first of all, revise the process to your third or fifth iteration of process, and how long did it take you to find the rules so that you come to a, what you call, relevant number? And how much it was relevant for you at this stage, at this time?
At first, the meetings, I'm sorry, the question was, how long did it take us to revise the meeting format and the process by which we generate the clash detection numbers? And I'll take that one, and then Tommy can discuss the time it took to address the rules. When we first began the clash detection process, and the number was enormous, everyone was looking for ways to streamline the process. So our first meeting was in November, and we intended to have weekly meetings, but without more time to actually work in the model, weekly meetings didn't seem like much of a good idea. So we had meetings every other week so that we had time to work, but all the while we were streamlining, the way that we could have these meetings more often and get there faster, because we were expected to sign off on coordination in February. Well, we didn't end up doing coordination until May, so that process was a lot longer than anyone had anticipated. But to answer your question, we found that in about 3 or 4 weeks that we could have meetings weekly, but then we didn't see the numbers decline as rapidly as we wished. So in the building, there are 2 subgrade levels and 5 above grade levels for a total of 7 levels. And we had, and the below grade ones were signed off first, but we had these like 3 or 4 levels to go, meaning level 1, 2, 3, and 4. And we eventually took control of levels 1 and 2 completely. So we did 1 and 2 totally in-house and left 3 and 4 for the outside consultant to manage and eventually, declare coordination. So to answer your question, it took us at least a couple months to figure out that we wanted to drive the process, that we wanted to own the files, and we want to really be the one who manages the process. And like I said, it took, let's see, March, April, May, it was probably a 3 or 4 month process to really go through this entire building and get from 30,000 to 3,000 to 300 to, and I think at we actually had the contractor signed off this week on coordination, and we were left with 14 clashes in the last email, and of those 14, there were 5 that were non-issues, 2 that were genuine clashes that we needed to move, and the rest he was like, whatever, forget about it, I'll take care of it. So, Tommy, you want to talk about the rules?
Yeah, well, obviously, we were kind of flying in the dark a little bit, starting out using selection sets and certain things, and finding out disadvantages along the way that held us. We ended up having to do a couple of things twice. Not being able to export. Yeah, we kind of learned. I mean, the rules took time. It really did, because by the time we created them and started to look at numbers go down and figure out if things were accurate or things were not accurate, it was a learning curve for us all in the office, and it was definitely a time-consuming period. Definitely a matter of a month, maybe more, by the time we tweaked it and got it to where we were confident that the rules were working. Because I can't tell you how many times we created sets, applied them, and didn't get numbers down. Created sets, applied them, got numbers down a little bit, did the same test again, got them down much more. And, kind of had to figure out the ins and outs of these rules. They're what it is they're telling you they're doing, how you get the best out of them, how you manipulate them, and how you apply the geometry to them. That was critical. And then after that, how you take advantage of your hard work and export it from one file to the next, because you don't want to do that again. So there was a lot of time spent on getting up to speed and jumping in the deep end there and trying to make that work for us. It was, the next time around it will obviously be nothing, but the first time in, sure, it was something that held us back at first, yeah.
Well, and just from my own perspective, I've been using Revit for a while, and it's as complex as you can make it, but I had no idea that this is what Tommy did with all that time, and it's clear to me that Navis has just as much power and has just the same learning curve that Revit does, so. I think it's impressive, yeah.
How much, time and investment did you sort of place in policing the model that you talked about earlier? And how important was that for you, Tommy, in creating your selection sets and search sets? And this is a two-part question. Being that you guys are the consultants and it was sort of an in-house job, in policing that model, would you have been able to achieve the same goals if you had multiple consultants who were sort of putting the information inside the model, and you trying to manage the process by extracting that information?
So to paraphrase, the way that I police the model, you know who you need to watch. If somebody's new to the program, you know that you can tell them to go ahead and do some work, and then you go and check up on them. And it's obvious if they lay down an entire floor of ductwork with no vertical elbows that they probably aren't watching what they're doing in 3D. So as the deadline approaches and you get additional resourcing to help you get that final push to the deadline, you keep an eye on these people. And how much time does it take? For me personally, not a whole lot. It's pretty obvious that, if you see clash numbers go up instead of down, it's obvious that the new people aren't doing what they should be doing, and depending on who you assign that area to, you have to go reprimand them and adjust the way that they work, because it's not like CAD. And Tommy is working on a different project where work sets are extremely important for the ways that the plot sheets turn out. So he can tell just by looking at the sheets if somebody's using work sets or not, because the work sets are used to define what level it comes in at, because the floor elevations are all over the place. So.
Well, we just need to point out we don't favor using work sets to control visibility at all. It's just that we're left up against it because the plan region functionality in Revit MEP just is useless. So our back's a little to the wall, so work sets unfortunately have to be used to control visibility. It would not be a way that I would, you just leave yourself wide open there, but we really have no choice. So yeah, policing the model is now up the level in our office, that's for sure.
And the time invested, I would say, is not extremely significant, but it's important. And the second part of your question, I think, was how would you deal with an outside consultant where you can't enforce good modeling practice? I think that the only way that you could really deal with that is to use the most simplistic sort of Navisworks options. Like, systems are very important in the models that I make for model performance reasons, meaning like I don't want it to slow down because everything's on the default system. But if I can't control that, if that's not my model, then you have to start using other ways. And what other ways are there other than systems for things like pipe? There's not any. So for that reason, you need to impress upon your third-party modeler that you're doing it wrong. And I can't help you with the rules in Navis because you're not up to, your ability is not there. Sorry, can you repeat the other question?
Last question, I think, was how difficult would it have been for you to sort of create these rules and selection sets if information wasn't input in the model in the proper way? And the second part to that question, would you have, in creating those rules and those selection sets, did you have to advise the people putting the information in Revit to input it any differently in terms of creating those rules and selection sets?
All right, so I guess the main question here is, when creating selection sets, stroke search sets, and giving those values onto the rules, did I have to have any sort of special instruction or sort of trouble, I guess, with modelers, individual modelers that were going to ultimately be contributing to them? The obvious one to talk about is systems, because simply when inputting tolerances, I mean, for MEP, Revit a lot of it is about being able to isolate systems, because you're going to draw a pipe, but you're going to have maybe up to, depending on what kind of project you're on, you're going to have up to maybe 10 or 12 systems. So how do you tell Revit that one pipe does one thing and another does another? You put it on logical systems. Now, not everybody has time to do that. Not everybody knows how to do that. I mean, I know in 2012 they've made it a whole lot easier now to do it without thinking as much as you do now. But so it always boils back to the question is, how do you tell in a Revit model when two elements are essentially from the same family, from the same type, that they're different? That's always an issue for us. I mean, we like to use filters, but if, again, a filter needs a parameter. It needs to know why it's filtering something. So it really usually comes back down to people modeling correctly on MEP systems that are specifically set up and have a logical flow of energy through them. So yes, if, as I said, if someone comes along and models the chilled water for 2 days on an unassigned system, when I run that Revit model through the Navisworks, and I do I go and like search in and see where I can pull out all the pipes that are on that particular system, I'm not going to find their chilled water. So we're not going to see that clash, or however many they've drawn. So that was kind of critical, you know, for people to do that kind of. But apart from that, I mean, as long as people understood that we were going to be pulling information out of the model and just paid a little bit of attention as to what, you know, again, it also boils down to if stuff's, I mean, on the wrong work set and therefore it's turned off in the view, not going to be picked up again. So the very basic Revit 101, how to model with correct work sets, filters, systems, the stuff that people should be quite familiar with if they're anywhere experienced with Revit MEP, was essential, because modeling stuff that A, doesn't show up because it's not on the right system or it's not on the right work set, anything that takes it out of the Navisworks sort of view, yeah, that could really mess things up. So it's a very good question. Yeah, we had to make sure that anyone who's going to attempt to draw something, they knew that the predefined sort of methods that they had to use, and they were stuck into that workflow, so it would get fed right through to the rule. So from the Navis model, for the Revit model, from the modeler, straight back out to the rule that got applied to that search. Yeah, it's pretty important and quite difficult at times. And if it was external, that would have been, yeah, that would have been very tough.
Yeah, I'm basically a three-time novice with Navisworks, and I've also started working a little bit with slavery. And one of the things I struggled with Navisworks is another team had some success with it and went through their project. And they seemed to have a lot of information in their NWF file, the rules, the sets, and so forth. And I couldn't see any way to basically turn that into a template to then use it on other projects.
Yeah,
Slavery seems to handle that type of.
That's a good call.
Knowledge from one project to another. Am I missing something? Or?
Well, we're using. It's interesting you should say that. We've now on the latest sort of project we're doing, we're using Salibri. So we'll let you know how that goes. That's no bad reflection on Navis. It's dictated by the architect. They've decided to go with Solibri because they've done the tests, which we haven't done ourselves, but they've reported that they found it to be a little more sophisticated. I mean, it's essentially the same guy that's left Navisworks and started Solibri, as far as you know, and so it's coming from the same people, but he's probably up the ante a little bit, or so I've heard report. But yeah, I mean, that was one of our first problems. We were like, we've got this great NWF file, now let's make it work all over this damn project. But yeah, we tried saving as and messing with that whole thing, and everything just got turned upside down. The numbers we got out of that, we just couldn't even start to begin to figure out what it was doing. I'm sure if you took your time with it.
It doesn't seem like you can turn it into a template.
Well, the only way to do it is to make sure you use search sets, because they can be exported. And once you export those guys combined with the rules, you're bingo, that's it, you're done. Now, you will still have to recreate all your batches. I didn't find a way to export those guys. And you saw in one of those models, it was like 40 of them. So maybe there's a way to do that. We didn't see it.
So rules, batches, and use.
Yeah, so we were basically able to export when we used search sets, because what we did was we got burned pretty badly on selection sets, because we couldn't, whether that officially works or not, I'll never know, but we couldn't do it. We wasted a lot of time trying to get, calling a lot of Microsoft, I think, were one of them, and all sorts of like harebrained ideas and schemes, because I don't think anyone really understood what we were trying to do, because it's a difficult thing to explain. But we soon realized that go with the search set and it's a little bit smoother. So that probably was one of the more important lessons, actually. In many ways, the search sets are definitely the way to go. Selection sets, they just have a broader scope, at least I found in my experience, in being able to reach into multiple parameters and all your models and pull a load of stuff out in one shot. Where I found search sets, as I've said before, a little bit more refined, but ultimately the payback on those guys was worth it. So I guess the first way to a template is to spend a lot of time on those search sets and then just export them to a common file in your project folder or your server or whatever, and have anybody just go and dump them in a blank or a new NWF.
Okay, bring them into a new project.
Yeah, bring them in there and see how that goes for you.
I'd like to address this web question real quick. You make a good point that if you don't clash it, why model it? One of the points that I made the other day was that if you want it to appear on plan, it has to be in the model somehow. And what's easier to draw? Some sort of line work, or just throw pipe in there. And the path that we chose was to model everything, even the 1-inch sprinkler lines, even though we threw out immediately, that was one of the first things we threw out, was the branch sprinklers. They had to appear on plan. They had to be in the model. Why doesn't Autodesk provide a small bore pipe item that acts like wiring? I don't know, but if they did and it worked well, then we would choose that. So definitely that's perhaps an area of development for them.
So just that they signed on, obviously you haven't gotten any feedback from the contractor, but you worked with the contractor. I'm assuming they are pretty sophisticated in terms of technological understanding.
Yeah, they told us when they signed on that all their subs work in 3D and have for years, and this BIM thing is not new to them. And they've used this particular Clash consultant before, so they know the drill. But I still believe that this is a really ambitious project for them.
Are the contractors gonna model their stuff also? And then the following question is, I think Scott has done this on the question aside of Turner. Multiple file formats during construction, when contractors are starting to come with their own different AutoCAD files, different layers, where you have to start redefining the search sets on the construction site. Do you know what those guys are anticipating? Can we have them in here in a year from now to have the other?
No.
Once this thing is built, I believe it would be interesting to have
Absolutely.
a contractor tell us how much was actually worth having the model, and how much was worth modeling, and what could have been just thrown out of the model and never even bothered taking.
Well, so your first question was, what sort of coordination process does the contractor plan on doing? He's going to do a typical coordination process where, even though we've demonstrated to him this is one way that the building can be built, he does see certain ways that he can refine the design to save himself money. So we went the GMP route on this particular job. So whatever savings he can eke out of the design is his to keep, and props to him. But in one area that I know he's going to refine is the electrical bus duct. I've got this electrical bus duct that snakes like crazy because I'm not going to take time to reroute this one electrical bus duct to save on fittings, to save money on bus ducts, but he sure is. So in the conventional coordination process that he's done with his subs in 3D before, we'll get shop drawings, we'll get, they have the model, it's theirs to use as they choose, but they're still going to, this does not relieve them from the typical coordination process. And you had a question about rules. Tommy, you want to address that?
What was this, the rules on
So just knowing that it was not really a question.
how they were going to redefine them?
Are you going to get, actually, let me rephrase it, are you going to get shop drawings or shop models? And if there is AutoCAD or something else, are you going to flash them in-house for your own, or are you just going to say,
I'm going to stamp them approved as soon as I get them. No, to seriously answer your question, they will be submitting paper drawings, PDFs of drawings, because that's still what they work from in the field, and those will be. This is a typical construction job, except for the three-dimensional aspects of it.
Sign off. What are they signing off on?
The sign-off that we received this week from Dimeo, the construction manager, states that they acknowledge to Yale that this model is coordinated to an extent to where they are confident that there will be no change orders on this job, hence GMP. So they're committing to the price that's been agreed upon by Yale and Dimeo, that Yale gets the building and there's no additional cost by the change order process. Yes?
How about the structure or something wrong with the how do you handle that?
Sorry, could you be a little bit?
Say the structure, concrete, beam, something is different in the field.
They build it wrong?
Yes.
They build it wrong from our model. That won't be. We won't be worried about that.
For instance, I work in the state. Okay, the steel contractor missed a big beam in a model. They came back to us in 4 months and told us, "Oh, we missed a beam." I said, "Check the model." We didn't have it in there, so they had to pay us to correct the problem.
The engineer had to pay you? Had to pay your builder, or?
No, the steel contractor.
Why wasn't the beam in the model?
The sheet metal contractor and whoever had the problem.
But hold on, the beam was or was not in the model?
It was not in the model.
And why wasn't it?
They missed it.
You missed it? You didn't draw it, or?
In the fabrication
Oh,
model.
so in the translation, they missed it from your model?
No, they missed it from their model.
Yeah, I know, but they looked at,
It wasn't even on paper.
Did they remodel to create the fabrication model?
right.
Yes, and they updated everything, and they paid the contractors.
But with
So the steel was physically there, but it wasn't in any model or
It
documentation?
wasn't there on the document, and it wasn't there in the model.
Well, you put it in your initial model, and when they translated it, it got lost, and then in the fabrication model, it didn't get built. So it probably just goes back to the fabrication. Yeah.
I mean, I'm not familiar with the ins and outs of this contract, or if it's even different than our typical contract. But obviously, a failure on the part of the design team would most likely be paid for by the design team. I'm not certain. I'm sorry.
How do you deal with stuff that is called for in the specs, but never drawn or modeled anywhere? I'm working on a change order right now where the elevator contractor in their specs put structural steel support for the rails and just called out a quantity, every 14 feet. It's a high-rise building. And that didn't wind up in any documents anywhere. And now the thing is in court. And the defense is saying that it was in the specs, it's in the construction documents.
What's in the specs is in construction.
The deliverables on this particular job are specs and plans. The deliverables are the specs and the plans. The model is a bonus for the use of the construction team so that they have demonstrated to them one coordinated way of building the building. If it's in the specs or the plans, we own it. If it's not in the model, then, and it's an item that is, if it's not in the model and it's not been coordinated for, that would be, you know, on us. But if it's not in the model and they just don't put it in, then that's on them. It's in the specs.
Specifications, the spec book, and construction documents, one package.
Agree.
That's it. There's actually a clause in the specs that they call it mutually something, I forget the term, and that if it's in one or the other, it's considered, you know, in all.
Mm-hmm. Yeah, it's again.
Complementary. That's it. Mutually complementary.
This is definitely a typical job in the sense that specs and plans are priced and all of that, but that the model is essentially a bonus item because Yale finds value in the coordination that we perform.
Now,
Go ahead.
now, I'm concerned because your design for this project, you had stated was you definitely have basically, you're looking for a very elegant building with very low profile floors so that it's basically somewhat of a transparent building.
Yes, correct.
And my concern is for the future and what may happen in terms of remodeling. What may happen in the future with technology if they come in and they have to do some retrofitting or whatever. Are your tolerances so tight that that is going to be impossible?
Well,
because you're trying to get down to zero.
This is actually tying into that lawsuit.
Agree. The to tie into what James led with regarding, you know, coordination and clearances, as you see in those lists of tolerances, the numbers that we've accounted for means that you could have a corridor where everything touches, right? Because we didn't think it was a clash unless two objects were trying to occupy the same space. So pretty much everything in these tightly coordinated areas touches, and that's something that Dimeo are aware of, and they signed off on the list of tolerances, and it's buildable.
Buildings that are just too tight?
From my point of view, absolutely, but I have to also concede that if you've got extra space above the ceiling, what's the point? So, but to kind of answer the question that you started with, if they need to remodel, what options do they have? The majority of this building. You're right. Correct. And I agree with that. But to answer the question that you asked, there are certain areas in this building that are very, very tight, and we have demonstrated that they're buildable with zero clearance. Is that typical for the whole building? No. It's mostly that lower level in the corridor where all the pipes converge and all the ducts converge. There are very, very few areas in this building where we have literally a packed house, like zero clearance.
Today's classroom is not going to be the classroom 50 years from now.
True. And the systems in the classrooms have a certain room to be retrofit, but the area in the building, you're right, the client might not have the flexibility that they're looking for in their building when they choose to remodel, and that's not something that I can say if they have or haven't considered. Yes?
It appears you spent a lot of time going through this process for a better liberal, and it's also important to make the distinction that it's a design side modification versus eliminating the efforts that would need to be done just what needs to be done on the construction side. How was that dealt with in terms of the contract and the design schedule and the customer? Basically put it to a corner where you had to do the same.
The contract was negotiated, it was renegotiated in about 2008, and at the time we had drawn the whole building in AutoCAD. And when Yale approached us and said, look, we heard about this new program, we're really excited, you guys should consider doing it, I was really excited about it. I told them to jump at it, and they, the people who win the work and write the contracts, they're like, all right, we're gonna go for this. So they submitted a proposal. They said basically, you need to give us an additional 2 months to take out all the work that we've done in design development and redo that work in construction documents. And in addition to that 2 months, we're going to want more fees for the amount of time that we spend modeling, and that's a modest increase. But on the assumption that this would take us more time to coordinate in 3 dimensions, we added in a ton of money to be compensated for this process, and they accepted the proposal. So the fees at the time were generous, and then when the economic recession, whatever you want to call it, then this project became a real good project for us because it had solid fees, lots of time. We had the resources, and the client saw the value in the design side coordination, and we were compensated for it. And can I say if we have made money or not? I can't say because I personally don't know. I can't say because I don't know, not because I don't want to tell you. But yeah, we got paid. We got paid for the effort, and they recognize the value of Yale.
Then I have a question about you use energy. Do you use any of the analysis tools in Revit? Calculate duct sizes and things like that, or do you use any such?
The duct sizing tool actually really depends on constructing your ducts such that the flows add up, which is good practice. But even when you do it, like the way that the duct sizing tool works is that you need to lay the whole thing out and then apply one sizing factor to the whole system. It's not the way that we actually design ductwork. So I still lay it out with my ductilator and a calculator and with the rules that I have written on the side of the ductilator. So the duct sizing option, it's just not there. I mean, would I use it for work? Absolutely. Does it work in 2012? Can't tell you. Does it work in 2010? No, it doesn't. So the load side is similar to the sense where it works, but the loads package is too dependent on the architect's model, meaning I rely on architectural model for the walls to be well connected, for the windows, walls, doors, floors to be modeled with meaningful geometry, dimensions. I have zero control over an architectural model. So relying on the architectural model for the loads of the building is not something that we're confident in. So for that reason, we haven't used the load side of it, because we have people who use programs that they know that they're quick in, that they can, I mean, for buildings such as this, you can whip up a loads model in 2-3 days and have great results out of it in 4. So, and then you'd have to compare Revit's output to that. Is it the same? Is it different? We haven't put in the front end investment to try and use it yet because we know it's just not there. Now, I hear that in future versions of Revit, they're really working on this and they're going to include some sort of energy considerations into it. Once they make this program loads and energy, we'll put in the time to figure it out because it just can't do energy modeling right now. I can do loads and energy analysis in IES. I can't do that in Revit. I'm not going to invest the time until I can make this my drawings, my loads, my energy. It's got to be really, really tight to take over that role.
And they're also focusing, because we were up there recently, and they were saying that they're focusing quite heavily on calculation, validation. So they understand completely that one of their biggest concerns right now is why people are using, third-party software when they're trying to get it into Revit. So they understand that if someone's going to use a calculation, they want to go to the exact formula that was used to produce that figure and investigate it. So they spoke a lot about really investing heavily in validation of whatever you're going to get out of a Revit model, which I think would give a lot more confidence. And if it made it easier for firms like us to be able to perform those kind of calculations and actually see where it's coming from quite clearly and explain it, and that would be better too.
Yeah, we addressed this one.
Any other questions, suggestions, comments? Everybody get a certificate that needs one for AA credit? Yes? Thought it was going to be a lot. Everybody sign the sign-in sheet? Let's give another big round of applause for our
you.
See you in July for the continuation of Summer of Engineering. Thanks for coming.